Hey everyone, welcome back to the Edexcel IAL Maths series. So today we're going to discuss the October 2023 paper of the Pure Maths 3. All right, so let's see the first question. A curve has equation y is equal to f of x, where f of x is equal to x squared minus 5x plus ex. Show that the equation f of x is 0 has a root alpha in the interval 1 to 2. So what we do simply is to just plug in 1 and 2 and see what the signs are. So f of 1 is 1 squared minus 5 times by 1 plus e. And 2, f of 2 is 2 squared minus 5 times by 2 plus e raised to power 2. This thing turns to 1 minus 5, that is minus 4 plus e, and 4 minus 10 plus e squared. So basically minus 6 plus e squared. So minus 6 plus e squared. So this one is less than 0 because e is 2.5 something, but this one is greater than 0. So sine of f of x changes between 1 to 2, therefore root lies in this region. Okay, now the iterative formula where with x1 equals to 1 is used to find an approximate value for the root alpha. Find the value of x2 to 4 decimal places. All right. So over here, if x1 is 1, x2 is going to be 5x1 minus e raised to power x1. So in this case, this is 5 times by 1 minus e raised to power 1. So 5 minus e. So this goes, oh sorry, square root 5 minus e. So 5 minus e, that is 1.510, 4 decimal places, that would be 5. Right, okay. Find by repeated iteration the value of alpha, giving your answer to 4 decimal places. All right. So C, we need x3, so we will start out with saving this value first. 5 times by answer minus e raised to power answer. So the first value we get is the second value, obviously, 1.513. Then we get, now it's the second value, third value. So 1.738883. Fourth value, 1.73305. Fifth value, after that it is giving us matter. So sorry, I made a mistake over here. So x raised to power 5, sorry, x5 would be 1.73418. Keep going. We will get 1.733 9, 6, 7, 1.7, 3, 4, 0, 0. And a few more tries. 1.7339. All right, so we need it to 4 decimal places. So that means we need to keep looking at the fifth decimal place also. So where the fourth decimal place starts to become constant and the fifth decimal place is not able to round it up, then that would be the case over here. So as we keep going over here now, as you can see, the values will start to become constant for this. Now, even if we try again, we will get the same value for 5 decimal places. Right. So now, therefore, alpha is going to be 1.733. Actually, this would become 40. Right. Okay. So that was the question. Easy. Let's move on to the next question. Function f is defined by f of x plus 3 divided by x minus 4. Find f of x. So over here, this is the function of a function. So first over here, we will have to find out f of 6 first, and then we would plug it back into the function. So first we find out f of 6. That would be just simply 6 plus 3 divided by 6 minus 4. So 9 over 2. So 9 over 2, simply, or 4.5. Now, when we plug 9 over 2 into the function back again, so you have 4.5 plus 3, 4.5 minus 4. So that is 7.5 divided by 0.5. So 7.5 is 15 over 2 divided by 0.5, which is divided by 1 over 2 squares. Flip, cancel. We get 50. Okay, so same way, just like we did over here. Same way we did over here. Let's 6 over here. Then answer plus 3 divided by answer minus 4. We get 4.5. And then we get 50. That's it. All right. Now find inverse of f. So we need to find the function inverse. So we have f of x equals to x. Let's start with y. X plus 3, x minus 4. Rearrange it. This becomes xy minus 4y equals to x plus 3. We make x the subject. Xy minus x is equal to 4y plus 3. This can be written as x, y minus 1 equals to 4y plus 3. X would be equal to 4y plus 3, y minus 1. And finally, f inverse of x can be written as 4x plus 3 divided by x minus 1. So that's the inverse of that. Function g is defined by g of x, x squared plus 5, and x is greater than 0. Find the exact value of a for which g f of a is 7. So first off, we need to find the function of a function, or the composite function, g f of x, g f of x, which basically means we are going to plug, instead of x squared, we're going to plug in f of x squared. So x plus 3, x minus 4 whole squared, plus, what was the question? Sorry. 5 equals to 7, right? 7. Okay. So instead of x, we can, we can, since we're finding the general function over here. So we can keep it over here. We don't actually have to find out anything yet. So when we plug in g f of a, this becomes a plus 3, a minus 4, whole squared, plus 5, equals to 7. Now we have to do that. So you have a plus 3, a minus 4, equals to 7 minus 5, 2. When we take the square root, you get a plus 3 over a minus 4 plus and minus square root 2. All right. Then we need to find out the values of a. So what we will do, cross multiply with two different values. So a plus 3 equals to root 2 a minus 4. And the other would be a plus 3 minus root 2 a minus 4. So over here, this becomes a minus root 2a, and root 2 times by 4 minus 3. So a becomes 4 root 2 minus 3 divided by 1 minus root 2. And a on this side plus root 2, plus root 2a, and then 4 root 2 minus 3, and a is 4 root 2 minus 3 divided by 1 plus root 2. All right. So over here, minus 3. Oh, sorry, this is minus 4 root 2. Minus 4 root 2. According to the question, we had to find the exact value of a. So that means that it's most likely that both of these will not be considered. So we will have to see which one we will have to consider first. So how do we do that? This is a composite function. So what we actually did over here, let's do this. So inside the input parameters or the domain for g, we are placing the entire range for f of x. So domain of g is range of f. Range of f, did we make it over here? We did not. You could actually make it into, you could do the long division and find out what the range is, but it's not important over here. However, what is important over here is that the domain of g of x must be greater than 0. So that is one problem that we need to see, that the domain of g must be greater than 0. So the values that we are getting, this one or this one, should be greater than 0. Otherwise, they cannot be considered, right? So if we plug this back into the f of a, if they come out to be positive, then they will be selected. If they come out to be negative, we will not select them. So first off, let's see. Minus 4 square root 2. We just need the value. After this, we will rationalize this also. So 1 minus square root 2. This is this value. Now we plug this into the x plus 3. Yeah. So answer plus 3, answer minus 4. So this is greater than 0. So this is done. However, going back, all right. So we have 4 square root 2 minus 3 divided by 1 plus square root 2. This selected. Now answer plus 3 divided by answer minus 4. This is less than 0, so obviously this will not be selected. So this means that A that we are selecting is minus 4 root 2 minus 3, 1 minus square root 2. Right. So this means that f of A is greater than 0. Right? So this is what we need. Now we rationalize A. So A is equal to minus 4 root 2 minus 3 divided by 1 minus square root 2 times by 1 plus square root 2 divided by 1 plus square root 2. The denominator simply becomes 1 minus 2. The numerator will come 4 root 2 plus 3 times by 1 plus square root 2. Now let's see. So this minus and the minus 1 in the denominator, we can cancel them out. So we are getting 4 root 2 plus 4 times by 2 plus 3 root 2. So 8 plus 3, that is 11, and 4 plus 3, 7 root 2. So that is the final value of A. Right, okay, moving on to the next question. Using the identity for cos A plus B, prove that cos 2A is identical to 2 cos squared A minus 1. This is easy because cos A plus B suggests that this is cos A, cos B minus sine A, sine of B. If it is cos 2A, that means this is cos A plus A. So this would be identical to cos A minus sine A, sine A, which becomes cos squared A minus sine squared A. Over here, there is no sine, so we need to substitute for the sine. So we know that sine squared A is going to be 1 minus cos squared A. So we substitute this over here, continued. So cos squared A minus 1 minus cos squared A. When you resolve the signs, you get 2 cos squared A minus 1. All right. Hence, using algebraic integration, find the exact value of this thing. So this is why we needed to convert the cos squared into the double angle form, because we can't integrate the square cos. We have to convert it into its double angle form. So integral of 5 minus 4 cos squared 3x. So first off, we need to convert the 4 cos squared 3x into its double angle form. So double angle form would be, if you rearrange this thing into the double angle form, you will get 1 over 2, 1 minus cos 6x plus, sorry. So this means that 4 cos squared 3x would be 4 divided by 2, 2, plus 2 cos 6x. So integral of 5 minus 4 cos squared 3x dx becomes 5 minus 2 minus 2 cos 6x dx. Identical to. And the limits will stay the same, pi by 12 to pi by 8. Right, okay. So 5 minus 2 is going to be 3. So this is just 3x. And minus 2 cos 6x. So the integral of cosine is sine. So positive sine. So this becomes 2 sine 6x divided by the derivative of 6x, which is 6 itself, from pi by 12 to pi by 8. Now we plug in the values. So 3 pi by 8 minus 1/3 of sine 6 pi by 8 minus 3 pi by 12 minus 1/3 of sine 6 over 12 is 1 over 2, 1 over 2, so sine pi by 2. Sine pi by 2 is 1 basically. So you have 3 pi by 8. This is 3 over 4 pi. So we should know the values by now. So sine pi by 2 is 1. Sine 3 by 4 pi. 3 by 4 pi is 270. So minus 1. No, sorry. 3 by 4 pi is, my bad. 135, sorry. 135. So it will have the same value as pi by 4 and also positive. So 1 over, sorry, square root 2 over 2. So just to show, radians sine 3 pi divided by 4. Yes, square root 2 over 2. Yes, all right. So let's do that. Right. So 1/3 of square root 2 over 2 minus 3 pi by 12 minus 1/3. Now, when you remove the brackets, we can deal with the signs. So this becomes negative, the other one becomes positive. Right. So 3 pi by 8 minus 3 pi by 12. So 3 divided by 8 minus 3 divided by 12. That is 1 over 8 pi. So pi by 8 minus these two. No, sorry. No. So you will have 1/3 of square root 2 over 2 minus 1. Because this one is positive and this one is negative. So minus 1 to take care of that plus sign over here. Alternatively, what you could have done over here is pi by 8 plus 1 over 3, 1 minus square root 2 over 2, which is exactly the same thing, just rearranged version of this. So pi by 8, this would be 2 over 2 minus square root 2 minus 2 over 3 times by 2, 6. So what do we need over here? We need the exact answer. Yeah, so that is the exact answer. Or if you go with this way, this would become pi by 8 plus, same reason, 2 minus square root 2 divided by 2 times by 3, 6. Either way, they're both the same thing. All right, moving on to question number 4. A new mobile phone is released for sale. Total sales N of this phone in thousands is modeled by this. where A is a constant, T is the time in months after the phone was released for sale. Given that T is equal to 0, N is equal to 32. Find the value of A. So there's only one unknown over here in this case. We can find out easily. So at T is equal to 0, N is 32 equals to 125 minus A e raised to power. This is going to be 0. So just 125 minus A. So 125 minus A. So this means that A is 125 minus 32. So 125 minus 30, oh sorry, no, 93. Now, given that when T is equal to capital T, the total sales of the phone was 100,000. Find according to the model the value of T, give your answer to 2 decimal places. So first off, we would need to linearize that. We would need to take ln because we are finding the T value that is in the exponent. So first off, N is equal to 125 minus A exp. The value is minus 0.109 T. Right, okay. So first we take ln of both sides. So this becomes ln n equals to ln. Actually, no, wait. Let's rearrange it first. So you have A exponent minus 0.109 T equals to, since we're looking for T, so we can rearrange it that way. So 125 minus N, right? So e raised to power this would be 125 minus N divided by A, right? And now we can take the ln. So minus 0.109 T is going to be ln of 125 N over A. So T would be, see, we're going to multiply the minus on the side, so that flips the ln fraction. So 1 over 0.109 ln A over 125 minus N. Right, okay. When N is 100,000, again, N is 100,000, but the value that we are getting over here, this is in, when not N, the total sale was 100,000, but N is represented in per thousand. So this is going to be just 100. So therefore, T is equal to capital T. So T is going to be 1 over 0.109 ln. A we found out to be 93 divided by 125 minus 100. So we get 1 divided by 0.109 times by ln 93 divided by 25. So that is 12.0525. And have they given us anything? We need to give that in 2 decimal places. So 2 decimal places would mean 12.05. Right, okay. Find according to the model the rate of increase in total sales. Rate of increase in total sales, that means dn over dt. Giving your answer to 3 significant figures. Okay. So C part. So n is equal to 125 minus A E, and now we know A, 93 minus 0.109t. All right, so dn over dt. 125 derivative is 0, so this becomes minus 93 times by minus 0.109 times by exponent 109t, or e raised to power that. So 93 times by 0.109, that is 10.137 exp minus 0.109t. Now, when t is equal to 7, that's what the question was, right? Right, okay. T is equal to 7, 10.137 exponent minus 0.109. 7. So answer times by e raised to power minus 0.109 times by 7. So we get 4.7265. Now this n is in per thousand. They're not asking about the n. They're asking about the total sales. So rate of sale, that would be 4.7265 times by 1000. So we get 4726.5, or approximately have they given us any condition? Three significant figures. Okay, so then it's fine. So 730. Okay. Okay. The total sales of the mobile phone is expected to reach 150,000 using this information. Give a reason why the given equation is not suitable for modeling the total sales of the phone. So the reason is stating right over here. So total sales means n total would be maximum 150, but this thing has capacity of 125. So let us explain over here. So when you have e raised to power minus x function, the graph looks like this, right? So this is e raised to power minus x. When you do minus thing, sorry, this is plus, but when you do minus e raised to power minus x, obviously this would go this way. Now, furthermore, if you do 125 plus e raised to power minus x, so this would be somewhere over, yeah, so somewhere over here like this, where this would be the maximum capacity would be 125. So this model cannot even go to 150,000. So we would say the current model is limited to a maximum sale of 125,000. So the maximum sale that we can get from this model is just 125,000. All right, let's move on to question number 5. Curve C has equation y equals to ln x squared plus k divided by x squared plus k, where k is a positive constant. Show that the dy by dx is this expression. All right, so this is a quotient. So y equals to ln x squared plus k divided by x squared plus k. So this is a quotient of a function, quotient of two functions. So u is our ln x squared plus k. U prime would be 2x over x squared plus k. V is x squared plus k. V prime, just 2x. And v squared, just that squared at all. So dy by dx. So quotient rule, uv prime. So 2x ln x squared plus k. Oh, no. Sorry. Quotient rule. Vu prime. So this first. So 2x x squared plus k divided by x squared plus k minus uv prime 2x ln x squared plus k whole divided by the square of x squared plus k. Now these two cancel out. What are we left with? Simply 2x. Now notice this is 2x also, this is 2x also. So this is 2x, 1 minus ln x squared plus k divided by square of x squared plus k. Now let's see what was the term. Yeah, all right. So that's what we have. So the outside is 2x, b is just 1. So a is 2, b is 1. That's it. All right. Given that C has exactly 3 turning points, find the x coordinate of each of these points, give your answer in terms of k where appropriate. All right. So the same dy by dx that we have found, we will plug in equal to 0. So dy by dx equal to 0 at turning points. So the same function that we have over here, 2. So when you put this thing equal to 0, the denominator multiplies with 0 on this side. So this means that you have 2x 1 minus ln x squared plus k equal to 0. So furthermore, that means either x is equal to 0 or ln x squared plus k equals to 1. So just one by one put them equal to 0 basically. So this condition is only met when you have ln e. So ln e is 1 basically. So that means x squared plus k is e, and x we are trying to find out, right? So x is e minus k squared, sorry, and x would be plus minus square root of e minus k. And have they given us any condition about? Okay, so x is equal to 0 is also acceptable. All right. Find the upper limit to the value of k. Find the upper limit to the value of k. So the k value where we are actually using, we are using in the denominator and in the ln function over here. Oh, okay. So basically we found this over here, right? So k, whatever k is, has to be satisfy this. It has to satisfy this. So we know that when you have square root of negative numbers, these are not real solutions. These are complex solutions. So this is not part of P3 or P4, but important knowledge. So that means that e minus k has to be greater than 0. So therefore k is less than E. Yeah, that's it. That was the condition. All right. So that was the third part. Okay. All right. Moving on. So that's the C part. An area of the sea floor is being monitored. The area of the sea floor, S kilometers squared, covered by coral reefs, is modeled by S is equal to PQ raised to power T, where P and Q were constants and T is the number of years after monitoring began. Given that log 10S is equal to 4.5 minus this, find, according to the model, the area of the sea floor covered by coral reefs when T is equal to 2. So we just have to plug it into the log equation. So log S, when we don't write base over here, that's implied as 10. 4.5 minus 0.0062. So 4.5 minus 0.006 times by 2. This is 44.988. So that means S is equal to 10 raised to power 44.988. So this 10 raised to power answer, you get this value, 9.7. No, wait. 40. Oh, sorry, I made a mistake. This is 4.5. Okay. So raised to power 4.5 minus 0.006 times by 2. 30. So this is 3760 point S is equal to this, basically. So that's all we need to know. So 10, so S is equal to 10 raised to power this 4.5 minus 0.006 times by 2. That is 3760.968. So we can convert it into 3 significant figures. So that would be just simply 30800. Now, find a complete equation for the model of the form, given the value of P. Okay, so basically we just need to compare these. Right, so we have log S is equal to 4.5. You can write it as log 10 minus this can be written as, again, same way, 0.006 t times by log of 10. So this becomes 10 raised to power 4.5. This becomes, times by 10 raised to power minus 0.006 t, and that is equal to S. Now all we have to do is to simplify this, and Q would be basically this thing. So we just solve for this. So 10 raised to power 4.5, we get 31,622. 76, and Q is 10 raised to power minus 0.006. So we get 0.98628, and how giving each to 3 significant figures. So therefore, 31,600 and this is 0.986. Right. So S would be 31,600 times by 0.986 raised to power t. With reference to the model, interpret the value of the constant Q. So this 986, basically, if you and try to understand this, 1 minus answer, this, and times by 100. So every time, every year, there is a decrease in the area of coral reefs by 1.372%. So that's what it's telling us. So this is sort of like a multiplier, percentage change. So the final C, so 0.986 is 1 minus 0.98, sorry, no. Represents decrease in area by 1.372%, because this is actually the 98.6%, right? So every year, so Q represents or indicates that the coral reef area is reduced by 1.372% every year. That's it. All right, so move on to question number 7. Figure 1 shows a sketch of the curve C with equation y is equal to f of x, where f of x is equal to e raised to power minus x squared times by 2x squared minus 3 whole squared. Find the range of f. So first off, we can see this over here that the range is like greater than 0, and this is the maximum value that we must find out. So if we plug in f of 0, we know that this is on the y-axis. So we get e raised to power 0. 2 times by 0 is 0, so minus 3 whole squared. So that is 9. And this is going between, this is going from 0 to 9. How do we know that it gets to 9? Because although e raised to power x squared will never reach 0 by itself, but the 2x squared minus 3 can squared also will go to 0, because this is what these roots represent. So range is between, so f of 0 is e raised to power 0, 0 minus 3 whole squared is 9. So range is 0, f of x, 0 is included, and 9 is included. Show that f prime of x is this. Okay, so over here we have to use the product rule. So f of x is equal to ex squared negative 2x squared minus 3 whole squared. All right, so u is our exp minus x squared, and v is 2x squared minus 3 whole squared. So u prime would be minus 2x e raised to power minus x squared. V prime, on the other hand, first we will reduce the power, 2x squared minus 3. Then we multiply by the derivative of this 2x squared minus 3. So that would be just 4x. So 8x times by that. So f prime of x is uv prime plus vu prime. So we have so 8x 2x squared minus 3 e raised to power minus x squared plus minus actually. So 2x minus 3 whole squared exponent minus x squared. All right, so did they ask us? Okay, so we need to simplify this. Okay, so if we notice over here, this is a common factor over here. 2 and the x are the common factors over here. And 1 of 2x minus 3 is also a common factor. So you have 2x minus 3 exp minus x squared. These are the things that are common. Times by 4. What if you just multiply this entire thing by 4, you get the first term. Minus, so we don't need to multiply anything with 2x, but 2x minus 3. So one more 2x minus 3. So we get 2x minus 3 e raised to power minus x squared, and 4 plus 3, 7 minus 2x. Now, what form did they ask us in? This thing. So wait. Oh, this was 2x squared. Sorry, my bad. 2x squared. 2x squared. So this was the form that they are asking us to leave it in. Oh no, sorry. Yeah, right. Okay. So given that the line y is equal to k, where k is a constant, intersects the curve at exactly 2 distinct points. Find the exact range of values of k. So y is equal to k. So basically this equals to some k. This is intersecting the curve. So intersects the curve at exactly 2 distinct points. Find the exact range of values of k. So at 2 distinct points, so if we notice over here, from here to here, from over here, so the up till these 2 points, like the maximum points over here. Aha, I don't know why it's not. Okay, never mind. This is this point over here, these two. So in between these 2 points, you have 2 distinct points along with this line over here. So k is equal to 0 will also be selected, but we will need to find out the x coordinates or the y coordinates of these maximum points. One we already know, so it's in between 9, but we need to find this. So to do that, we need to equate it to 0, and I think we talked about it in the start. We just need to put that equal to 0. No. Since we need the maximum point, so that means we need to put this equal to 0. All right. So maximum points. This is part C. All right. Maxima can be found with dy by dx or f prime of x is 0. So we put this entire thing. Oh, sorry. No. We put this entire thing equal to 0. So 2x 2x squared minus 3 exponent minus x squared 7 minus 2x squared equal to 0. So from this can never reach 0. So the rest of them will do. So from 2x equal to 0, you get x is equal to 0. From 2x squared minus 3 equal to 0, you get plus and minus square root of 3 over 2. And this one, that would be plus minus 7 over 2 root. So we can see this over here that these ones will be the square root 3 over 2, square root minus 3 over 2. We don't need the 7 anymore, 7 over 2 anymore. So from 9 to, we just need to find the y value of this. So y at x is equal to square root 3 over 2. That would be e raised to power minus x squared 2x squared minus 3 whole square. So x squared is just 1.5. So we get e raised to power minus 1.5, and 2 times by 1.5 is 3. So 2 times by 1.5 is 3. So 3 minus 3 is 0. So y is equal to 0 at that. Wait. Oh, okay. So they gave us this one. So that means we, sorry, no. My bad. So these were the 0 points. These are also stationary points, by the way. So this is clear over here. So these are 3 by 2 square root negative, and this one is positive 3 by root. So that means we need the 7 over 2, right? So y at x is equal to 7 over 2. So x squared would be just simply 7 over 2, 3.5. So y equals to minus 3.5, and 3.5 minus 3 whole square. So e raised to power minus 3.5 times by 0.5 square. So did they ask us for an exact value or find the range of values of k? Sorry, my bad. This is 2 times by 3.5x squared. No. 2x squared. So that would be 7 then. All right, 7 minus 3, 4 squared. So this becomes y equals to 16 e raised to power minus 3.5. So if we want to keep it in the exact form, the range will go from 16 e raised to power minus 3.5 to 9. Yeah. So basically that's it. Since they said k was greater than 0, so we can't include the 0 one. All right, so moving on to question 8. Prove that 2 cosecant squared 2 theta times by 1 minus cos 2 theta is identical to 1 plus tan squared theta. So 1 plus tan squared theta is equal to secant squared theta. So that means the left hand side should be coming in the form of 1 over cos squared theta, or 1 over actually the secant squared theta also would be fine. Now, first off, we need to deal with the left hand side. 2 times by cosecant squared 2 theta times by 1 minus cos 2 theta. So 2 cosecant squared theta can be written as sine squared 2 theta. But how do we how do we find an alternate for 1 minus cos 2 theta? Because we have 3 forms for that. One form is 2 cos squared theta minus 1 equals to cos 2 theta. The other one is 1 minus 2 sine squared theta equals to cos 2 theta. So, which one should we use? Since we want cos squared left out in the denominator, that means we need to cancel out, or we need to cancel out the sine component. So that means this is the we will use. So 1 minus cos 2 theta becomes 2 sine squared theta. Now, furthermore, what we do? We expand this 2 over sine squared. That means 2, sorry, 4 sine squared theta cos squared theta times by 2 sine squared theta. So 2 divided by 4 cancels. Sine squared gets cancelled. We are left with 1 over cos squared theta, that is secant squared theta. Now, right hand side, 1 plus tan squared theta is equal to secant squared theta, or identical to that. So therefore, left hand side is identical to right hand side. Hence, solve for 0 to 360 degrees where x is not equal to the multiples of 90, this equation. So that means we need to equate this thing with this thing. So instead of this, we will substitute this. So 1 plus tan squared x equals to 4 plus 3 secant x. So that means 1 plus tan squared x gets changed to secant squared x equals to 4 plus 3 secant x. So secant squared x minus 3 secant x minus 4 equal to 0. So this seems straightforward. Let's say you have x squared minus 4 minus 3x. So this becomes 4 and 1. So 4x minus x can only yield minus 3x, and this is negative. So you have secant x minus 4, secant x plus 1 equal to 0. So secant x is either 4 and secant x is either minus 1. Both of these values we can do. Convert this now into cosine. So cos of x is equal to 1 over 4. And cos of x is minus 1. Now this we get from 180 degrees, so obviously this is a multiple of 90 degrees, so this will be discarded. But cos 1 over 4, cosine 1 divided by 4, you get, first answer is this. So we know from the cos diagram that the cosine is positive in the first quadrant and in the fourth quadrant. So the same angle will be found in the fourth quadrant also. So 75.5 and then 360 minus 75.5 degrees. So 360 minus answer, that would be this. So 75.5 and 280, let's call it 284.5 degrees. Right, okay, moving on. Question number 9. Figure 2 shows a sketch of the curve mod 2 minus 4 ln x plus 1, where x is greater than some value k. Given that the curve has an asymptote at k, x is equal to k, cuts the y-axis at point A, meets the x-axis at point B, state the value of k. So asymptote over here is happening due to this thing. So this, at this point, you must realize this by now, that asymptote is caused by the ln term. So the asymptote is due to ln term. So ln x, where x approaches 0 basically. So obviously we can't have that. So we have x plus k over here. So that means x is minus k. Oh, sorry, they gave us 1. Sorry, my bad. Oh, that was that. Okay. So x plus 1. So therefore that means x or k is equal to minus 1. So it's actually coming from the argument. So that's what we want. So why? Because x plus 1 has to be like, or it's approaching 0 or equal to 0. This is what the ln function becomes undefined on. Now, find the y coordinate of A. So y coordinate of A is easy. We just plug in x is equal to 0. So y equals to mod 2 minus, is it 2 minus 4 ln x plus 1. And okay, all right. So x is equal to 0. So you get y equals to mod 2 minus 4 ln 0 plus 1 is 1. So ln 1 is 0. So this cancels out. So you were left with just 2. Right. Find the exact x coordinate of B. All right. So B is when y is equal to 0. So at B, y equal to 0. So 0 equals to mod 2 minus 4 ln x plus 1 equal to 0. So basically what that means is either you have, or no. So since the other side is 0, so it's just 2 minus 4 ln x plus 1 equal to 0. So this goes on the other side. So this becomes 4 ln x plus 1 equals to 2, which means that ln x plus 1 is equal to 1 over 2. So x plus 1 is equal to e raised to power 1 over 2. So x is exp 1 over 2 minus 1. Right, okay. This is second part, all right. Using algebra and showing your work, find the set of values of x such that this is greater than 3. Okay, so what we can do is we can take the square on both sides. So C part, 2 minus 4 ln x plus 1 greater than 3. So square on both sides. 2 minus 4 ln x plus 1 whole squared greater than 9. So what we're looking for is just, okay, so we use the difference of squares methodologies, 2 minus 4 ln x plus 1 plus 3 and 2 minus 4 ln x plus 1 minus 3 greater than 0. So we have 5 minus 4 ln x plus 1, and 2 minus 3 is minus 1 minus 4 ln x plus 1 greater than 0. All right, so basically we have this quadratic equation and we are finding greater than 0. So this means that we have two equations, 5 minus 4 ln x plus 1. Since we are actually trying to find the values or critical points, we are trying to find that. So when this is equal to 0 and when minus 4 ln x plus 1 equal to 0. So we have 4 ln x plus 1 equal to 5, and over here we have 4 ln x plus 1 minus 1. So ln x plus 1 is either 5 over 4, or ln x plus 1 is either minus 1 over 4. So this is not possible. Ln terms can't be negative. Sorry, the argument can't be negative. This can be negative. Sorry. My bad. So when we reverse the ln, we get e raised to the power 5 over 4 minus 1 equals to x, and the other one would be e raised to the power minus 4 minus 1 x equals to that. So we have two points over here. So which one is lesser? This one is lesser. So this one is lesser. And we need to remember over here that we have a minimum x value over here also. So it's between k to that point. So that means we have minus 1 to e raised to the power minus 1 over 4 minus 1, and x is greater than e raised to the power 5 over 4 minus 1. That's it. All right, so moving on to question number 10. A curve C has equation x is equal to sine squared 4y. Point P with x coordinate 1 over 4 lies on C. Find the exact y coordinate of P. So 1 over 4 equals to sine squared 4y. So that means sine of 4y is equal to plus minus 1 over 2. So y would be 1 over 4 plus minus 1 over 4. No. Sorry. 1 over 4 and sine inverse of plus and minus 1 over 2. Problem is that y is between 0 to pi by 8. So sine is always positive in that region. So we will just take the positive one. So plus 1. So we will discard this one. So sorry, this is going to be plus right? So 1 divided by 4 times by sine inverse of 1 over 2, that's 30 degrees. So pi by 4 times by pi by 6. No, 1 over 4 times by that. So, oh wait, I forgot. This is in radians. So pi 1 over 4 times by sine half. This is 30 degrees, pi by 6. So we should get pi by 24, and this is pi by 24. All right. So this is what you can write over there. So find dx over dy. Okay. So b part, right? So x is equal to sine squared 4y. So dx over dy. So first we take down the power. So this becomes 2 sine 4y. Then we differentiate sine. Sine derivative is cos 4y. And then we multiply by 4. So this is basic chain rule. So 8 sine 4y cos 4y. We can further simplify this also, but I think this is fine at this point. Hence show that dy by dx can be written in this form. Okay, all right, got it. So dy by dx is the reciprocal of this thing. So you get 1 over 8 sine 4y cos 4y. Now, the sine 4y is coming from this square root of x, and cos 4y can come from the fact that sine squared 4y plus cos squared 4y is equal to 1. So that means cos squared 4y is 1 minus x. So square root would be 1 root of that. So 1 over 8 square root of x times by square root of 1 minus x. So what did we want in this form? Okay, all right. Let's simplify this. Since we want everything inside the denominator, inside the square root, let's further simplify this. So 8 inside becomes 64. 64 times by x times by 1 minus x raised to power 1 over 2. So this can be written as 1 over 64 x minus x squared 1 over 2. Okay, this we can complete the square if we want. So 1 over 64 minus x squared plus x. You can take out the minus. So you can take out the minus. You can make this thing. So 1 over 2. So this is already 2 now. So that means this 1x basically represents the 2ab thing, the middle term of a square. So the half would be 1 over 2 whole squared, and then minus half squared. So completing the square, basic P1 1 over 2, we get 1 over minus 64. This becomes a square. X minus 1 over 2 whole squared minus 1 over 2, 1 over 4. This. Sorry, this is not 1 over 4. This is 64 times by 1 over 4. So basically, this is multiplied by all of these terms. So 64 divided by 4 is 60, right? So minus 64, x minus half whole squared. This would be plus now because you have a minus and minus sign over here, plus 16, 1 over 2. And I think that's the form that they wanted. Yes, okay, that's the form that they want. Using the answer to part C, state the x coordinate of the point, the value where the dy by dx is a minimum. So dy by dx being a minimum over here. So we don't actually have to take the further dy by dx, like we don't have to take the double derivative over here. So d1, that's what they wanted, right? Right, okay. So minimum dy by dx means where this is maximum. So dy by dx minimum implies maximum maximum of 16 minus 64 x minus 1 over 2 1 over 2 whole square. So we need to figure out where the maximum of this function is. So now what we can do over here, we can differentiate this if we want to, or even with the uh, power over here. So we can do that if we think about it. So wherever the maximum is of this function, so d by dx of 16 minus 64 x minus half whole squared is going to be minus 64 x minus half, power comes down times by 2, and then multiply by x minus 2, so that we don't need that. So we have 2 times by 64, that is 128, x minus 1 over 2. Right. So we need this to be, we need this thing, since we are already doing max of this, to be equal to 0. So we will get x is equal to half. So max, sorry, put this equal to 0. That's it. Now, what the question was, state the value of dy by dx at this point. So that means at x is equal to that. So we are finding the maximum value of this thing. So let's find out x. So when x is half, 16 minus 64, half minus half squared, that is 0. So that is just 4. So dy by dx, therefore, is 1 over this entire thing. So that's just 4. And that's the question. All right, moving on. Oh, that's the final question. All right, so that's good, finally. Right, so that's the paper. If you feel I was able, if you feel I was unable to explain a certain question properly, please do reach out in the comments. If you like this video and enjoyed uh, the learning style over here, please reach out in the comments and tell us what we can improve and what would you like to see in the future videos also. Don't forget to like, subscribe to this channel, and engage with us if you want tutoring for or preparation for the P3 and P4 papers. Do reach out to us. All right, so take care.